All right, so, and just a reminder, you can't say things enough times. And even when I do say things many times, somebody's still gonna ask me the question later, and that's fine, but that's what I mean, you can't say it enough times. So starting next week, right? Beginning on Monday, 12:30, so the group that's in today, group 3, right? You write the test first. Calculator textbooks, bring that cable with, right, that you used to charge. Make sure, by the way, they're fully charged when you come in. And so then group 2 and 1 accordingly. Okay, so Thursday, Friday, not much going to happen. You come online, I do attendance, and that's it. Okay, and then I'll probably dismiss you, and that's just how it is. What was I gonna say yet about this? Oh yeah, I did cover yesterday. I give you a short, summary as to what to expect, right? I narrowed it down, like chapter 7, word problems. Look at the 4 types, know how to graph, know how to come up with a domain and range. You know, regressions is big, right? The 4 types, we're talking regressions, right? And then chapter 6, word problems involving optimization. Chapter 8, word problems, being able to fill out a chart and scale factors, right? Scale factors involving one-dimensional, two-dimensional, and three-dimensional conversions, right? Know how to do that. And that's it. So just, oh, and it's in cabin 3, in person and cabin 3, right? It's right here in our classroom here that you're always used to be in anyways. So it's not in the cafeteria or theater. Okay. Okay. Let's do 1 or 2 questions in this review before I hand it over to you again. Okay. So page 14, question 5. This is chapter 6, right? A bicycle shops makes 2 types of bikes, mountain bikes and racing bikes, right? That should be a clear X and Y there. Yeah. Yeah, just on this desk here. Yeah, bring your textbooks. Okay. Let's continue reading. The profit for each bike is 250 and 210. That might only be these 2 numbers may or may not be part of your system of inequalities. We don't know that yet. Okay, let's keep reading. Each mountain bike requires 3 hours of assembly and 15 minutes for testing and adjusting, right? So this is mountain bike gets hours for assembly and minutes for testing. And then each racing bike requires 2 hours for assembly and 30 minutes for testing and adjusting. The shop can devote 120 hours for assembly, 15 hours for testing, and would like to make a profit of at least 40,000, right? So the last sentence here, right? Up to 120 hours for assembly, right? That would be one inequality right there. Okay, so I would say, right, that should have an inequality that goes with it. 15 hours for testing, so up to 15 hours for testing. There's a restriction on the testing. And a profit of at least $4,000. So that would be your third inequality. Okay. So I know that the table threw some of you off, right? So let's say you do get one of those again, right? And so this would be mountain bikes. Let's just organize it in a table, right? Mountain and racing there. And on the left side, we will have, I will do the attendance in a bit, okay? And along the left, what do we have there? We have assembly time, okay? We have testing time, and we have profit, right? Those are the three things that a chart, if you want to organize it in a table, that's what should be on that table, okay? And so then you organize it. For a mountain bike, it will take 3 hours, right, for assembly. It takes 15 minutes to test, and where would the profit be? For a mountain bike, it would be $250. Okay, it's right here. Then next we go for racing, the racing bike, right? It takes 2 hours for assembly. It takes longer to test, right? And it costs $210. So this is what a table would look like, which I didn't do a whole lot of, right? But it shouldn't throw you off. You can do that. You can organize things like that. Like, what are we talking about here? Oh, and notice that the three inequalities, right, have a row each. Now, sometimes there are certain restrictions that are exclusive to one variable. For example, if this would have had a statement saying the company would like to make at least 50 mountain bikes and at least 30 racing bikes, you have one inequality for X, which will be a vertical line, and one inequality for Y, which would be a horizontal line. Okay. Some of you are trying to add those up or whatever. They're just exclusive to each variable. Okay, so now you gotta come up with your inequalities. So the first one, I'm gonna make one for assembly. First of all, I should probably develop a system, include implicit constraints. I'm not telling you what the variables are here. So X would be number of mountain bikes. Y would be the number of racing bikes. And then my implicit constraint, which a lot of you forgot, right? Because you can't have negatives. So this is the first thing that it needs to be there unless it's already stated, right? So let's come up with our inequalities. The first one, right, up to 120 hours of assembly. So we're going to use the assembly time. And notice that this table could be flipped, right? It could have the mountain and the racing here and then have 3 columns like that. But you know that these values go with assembly. So that those coefficients with this restriction go together, right? So we'll go 3 hours for every mountain bike and 2 hours for every racing bike, right? In terms of assembly, that has to be less than 120. This is my first inequality, okay? My second inequality is a 15-hour testing maximum limit. So there's a bit of a problem, right? You have minutes and hours, and you decide if you want to convert this to minutes or convert this to hours. That's up to you. This is probably easier to just say this is 0.25 of an hour and this is 0.5, right? Half an hour. If you want to convert that right away, there it is. So it'd be 0.25x plus 0.5y, and that has to be less than or equal to 15. And so this is my restriction on assembly time, restriction on testing time, and they want to make a profit of at least 4,000. And that's going to cut into my graph here. So I'm going to do the third one here. So 250 per mountain bike, 210 per racing bike. That has to be greater than or equal to 4,000. A lot of you didn't do this part right. You got the coefficients and everything right. The numbers are supposed to be together, but you made this face the wrong way, right? So this has to be at least 4,000, meaning that this has to be 4,000 or greater, okay? So there you have your three inequalities, and they're all diagonal lines. So this is, right, there's going to be quite a bit of work involved in this one, more than what we're used to. So for the first one, I'm just going to go straight into x-intercepts, right? I'm not going to rewrite it again because I'm saying that I'm doing, right? I'm working with the first one here. 3x is equal to 120. Divide both by 3. X equal to 40, so that's 40, 0. Done. The next one is 2y is equal to 120. And this is just because we're now considering the boundary line. That's why we have equal signs in here when we're finding the intercepts. Divide both by 2. Y is equal to 60. So that's 0, 60. Box that in just to make it nice and clean, right? I'm going to rewrite it. So 2y is less than or equal to negative 3x plus 120. Divide everything by 2. Y is less than or equal to negative 3 over 2x. It's the little things that caused a lot of you grief, right? The little things. Right? Sometimes you didn't shade right. Sometimes you missed an inequality. And that caused you to do less work on the graph, which automatically you lose marks again because it's easier than if you had 3 lines, right? So if you see less work, that's what that means. So because it says y is less than, we know that below the line is the true region. So I'm just making a reference at where am I shading and that it is solid. And by the way, all the examples you have seen are solid lines, right? I'm going to try to save this space right here and work with the second equation here. 0.25x plus 0.5y. I shouldn't have copied it. I did it anyways. So that's 0.25x is equal to 15. Divide by 0.25. X is equal to, that's 60. I think it is. Divide both by 0.5. You get y is equal to 30, 0, 30. There's that. And then I'm going to rewrite it here. Negative, or sorry, 0.5y is less than or equal to negative 0.25x plus 15. Divide by 0.5. 0.5 y is less than or equal to, I think this is just 1/2 reduced, but you wouldn't, I'm just going to show it the way that you would probably do it if you don't want to make mistakes. This one would be 30. If you go 15 divided by 0.5, you get 30 there. And again, it's above that we're shading and it's solid. And that I box into the, I like the equation to stick out when I work with them. I'm not reducing anything if I don't have to, because that can just give me issues, right? All right, there it is. Next, the last one, x-intercept, y-intercept. By the way, you don't need to write x-intercept, y-intercept because I know the way you write it. I'm just so used to doing that. But whatever you need to do to save some time, right? 250x is equal to 4,000. So 16, right? Because 250 goes into 1,000 4 times. 4 times 4, yeah. Okay. And then we have 210y is equal to 4,000. Divide both by 210. And that one I'm going to need my calculator for to get it right. And that's 19.05. 19.05. Because for graphing purposes, right, it's better to have that instead of a fraction. I'm going to rewrite it, and that's 210y is greater than or equal to negative 250x plus 4,000. If you divide that, you get negative 25 over 21. I think that one you can handle, right? I just cancel the zeros. Plus 4,000 over 210. You could cancel the zeros there too, so it's 400 over 21. And this one is different. This one is below, and always it's solid as well. So write that down. I'm going to leave that for a bit there. So you can copy that down if you need to. It's also in the answer key though. It's not cooperating. Hold on. Good. That's graphic. Please label. I can't tell you how many of you lost marks there. Okay, number of mountain bikes. You're gonna get, if you don't learn your lesson, you're gonna learn it again next year, right? Like it's gonna happen. That you're gonna lose, like I call them easy marks, right? Just labeling. Number of mountain bikes, number of racing bikes, and use a consistent scale, which you know what, I am very proud of you guys. Like in that sense, the scales are really good. So we're gonna go 10, 20, 30, 40, 50, 60. The art of spacing them equally, you learned as well. Like you're doing pretty good on that. I'm gonna go 60 as well this way. So 10, 20, 30, 40, 50, 60, and that's good. Label every other one, save some time there. And we get 40, 0, 0, 60. That's my first line. And please use a ruler. Okay, that's my first line. And then my second line is 60, 0, 0, 30, In that sense, I also saw very few. I don't think I saw any of you flipping these, like putting a 0.30 on here like as 30.0. Like I didn't see that. So again, I guess I'll just write it out the way it is. It's not the best, but it is what it is. It's still accurate. And then the third line, we are at 16.0, 0.19. So right here, labeling that one, I will use the 250x plus 210y greater than or equal to 4,000. There. And I'm shading below on this one. It's the little things again, right? You will see now when I find the corner points that I'm going to show you another thing that stuck out to me that shouldn't have happened. But we're learning, right? As long as you keep trying, keep going at it. Okay. All the other lines are above, so safe to say that our solution region is here. That one was well done. Solution region was there. In this case, I know all these ones that are along the axes. I know those. I just need to find this one here. Okay, so I'm going to go ahead and find that corner point. And really, you don't need to type this one in. In this case, I wouldn't do that because it's not intersecting any of these guys, right? So you make it a lot easier if you just stick with those two. Negative 302x plus 60. Oops. Make sure you take some time and check if you typed it in right. And then the next one, this one here, negative 0.25 divided by 0.5 x plus 30. Let's find where they cross, and my window is way out, right? So I'm going to go zoom, just window, sorry. I just need like 70 here and 70 there. That's better. There you go. Second trace 5, enter, enter, enter. And that's 30.15. And I'm going to now state the corner points all down here surrounding this solution region. So I've got 0, this one here is 19.05. Then you have this one here, which is 16.0. Then you have this one up here, which is 0.30. Sorry, I'm not writing them. You can't see it, right? 0.30. Then you have 30.15. And you have 40.0. And this one here needs to be rounded. Okay, you can't, because these are number of bikes that we're making. So that's 0.19 or 0.20 or 0.19 because it's discrete, right? So some of you lost marks there because those are technically the possible solutions to the system. So it has to be rounded when you get a decimal like that. If you label them as a decimal on your graph, the way that's okay, but once you state your corner points, they need to be rounded. Write the objective function, then determine the combination that would maximize the profits. So to find out the maximum profit, right, you would go 250x plus 210y. It shows up again, right, those two coefficients, but now it's the objective function. That's usually worth 1 mark itself. And then you got to run all your corner points through this one. So 0.19 goes through there. 16, 0 goes through there, 0, 30, 30, 15, and 40, 0. And so this one only really goes 210 times 19. This one here is 250 times 16. This one is 210, 30. This one has both X and Y components. And this one has that. I may have in my key bump this up to 0.20. And that's okay. If that happens, I'm not taking any marks off for that. So this is 3990. This is exactly 4,000. This is 6,300. Ooh, almost made a big mistake here. That answer did not seem right. All right, so you have those. And then obviously you want to maximize the profit, so this is the maximum. And that's all, like, that's good. And then you say producing 30 mountain and 15 racing bikes will maximize profits. Okay, write this down, and then I'm just going to do 1 or 2 questions back in the conversions in chapter 8. You want some quadratic review?
Yeah, it's mostly quadratic.
Right. Yeah, I rounded it to 20 on my key, this one. And that's fine if you go, like, as long as it's not a decimal, okay? Okay, I'll do the measurement and then I'll go to quadratics. Do you have one in particular?
I had no idea how to solve the first page, but I think since it's more on word problems as opposed to I think we can cover that more.
Okay. All right, let's go to page 17, bottom of 17. Just wanted to go over that one more time. You wanted to convert question 8, where you're converting, squared units, cubic units, and so forth. So this is the classic error. I'm going to show you the classic error on a piece of paper. This is what I get, and even in grade 12, right? You want that to square feet, so it's like, oh yeah, I remember, right? 1 yard has 3 feet. Cancel, cancel, right? And that is 69, right? Feet. And it's like, right? That's wrong because you're canceling squared yards with just yards. So this is wrong, okay? What you need to do is take the 23 squared yards and you want to go to feet. So yes, at first you're just looking at yards and feet. And so what's the conversion ratio that gets you there? And it's the 1 yard, the fact that 1 yard has 3 feet. And so what do you need to do to this to make it squared? Well, you need to square the whole thing like that. And you just need to show that, right? And then you can cancel this with this. Okay, and then you're going to have to go 23 times 3 squared, which is 9. But you use your calculator for that, right? So it's 23 times, I'll just show you, right, times 3 squared. Whatever this ratio is, it could be 0.3048, it doesn't matter. You square it, and you get 207. That's what it's supposed to be, square feet. Okay, let me see here. Yeah, I'll jump to F here. So I'll just do A and F, okay? Checking. Yeah, let's do F. So 59 square meters times, you want to get it to yards. You're thinking and you know that 1 yard, you want yards here and meters here, has 0.9144 meters. Okay, that is true, but you cannot cancel meters with square meters. So you need to square this whole scale factor. And now you can cancel this with that. Now it's 59 divided by 0.9144 squared. Okay, so this is how you enter that. Right, just simply as that. And you get 70.56. So don't just think everything is linear. There might be linear, right? Just kilometers to yard to miles, whatever. But if it's squared or cubic units, you need to watch out for that. And my key shows you all of this, right? So you can just check and make sure. Don't spend tons of time on this, but again, you need to know this, okay? Let's go to quadratics then. $11. I'm thinking 11. 11 and 13 maybe. Are you okay with me going over it, or would you rather do your own thing? You can do your own thing too if you want to ignore me, that's fine. At this point, I'm not offended as long as you're doing something to help you prepare. Okay, so 11 it is, folks. So this is on page 3. This is under quadratics. Yes, you're going to need, this is one of the types. I'm thinking this is type 1, I'm thinking. Doesn't really matter, but it's a profit question. Okay. A hockey arena sells premium tickets for $85. At this price, the arena will sell 5,000 premium tickets every game. The owners have made upgrades to the arena and would like to increase the ticket price. They project that they will sell 250 fewer premium tickets for each price increase of $40.50. Okay, so something is happening there. They want to maximize profits there, and so you understand that, right? There's something, if you have profits and tickets, right, that is one relationship, and you can also have profit and price per ticket. They both give you a parabola. Okay, the more tickets you sell, the more profit, but after a certain point, right, the profit will start decreasing, and that's because the price kicks in, right? The more expensive the ticket, right, there's a certain point where you reach the highest profit, but then the higher the ticket, fewer tickets will be sold, so that causes your profits to go down. Okay. So A, determine the equation relating the price and the profit. So first of all, we need to fill in one of these tables. So we know that at $85, we're selling 5,000 premium tickets, which, right, the profit would just be $85 times 5,000. Then, if you increase it, so the problem is hinting towards an increase. So you're increasing this by $40.50. So that's $125.50. Right? So you're increasing this by 40.50. Okay? And what happens to the tickets? There will be 250 fewer tickets sold. So you go minus 250 here. So that's 47.50 on that end. Then it happens again, right? Plus 40.50. So that gives us 166. There. And then you decrease this by 250 again. So that's 4,500. Okay. So you filled in your price and your tickets accordingly. And so now we've got to fill in the profit. Column like this. And because our equation is going to relate price and profit, you have to make this your L1 and this your L2. Okay, so go ahead and type that in. So you've got 85, 125, 50, 166. And this is 85 times 5,000, 125.50 times 47.50, 166 times 4,500. There it is. And now you got to go stat, calculate, quad reg, equals second 1, comma second 2, comma vars, y vars, enter, enter, enter. There's your equation. I'm going to write that down. So let me just go over here. $173 if you round to 3 decimals. 2 is minimum. 5524.691 x, and there's no c. C is just 0, so that's the answer there. I'm going to go stat, calc, quad reg. Those are the keystrokes I use to get that. Don't worry about the L1, L2, or that stuff. Okay. So that's the equation. Then it's saying what price will maximize the profit achieved. So obviously you need to find the highest point, because that'd be the highest profit that you make. And so we're going to graph this now. So if you hit graph, you're not going to see much, right? Because I was just using, I still have that linear equation kicking around there, so I got to get rid of that. I'm going to turn on plot 1, and then I'm going to go zoom 9, which is just going to give me a partial picture. Then I'm going to go -5 here. I have a feeling that, right, it's going to keep going towards the positive x for quite a bit, so I'm going to go 1,000 there. -5 here. And I was at 80,000, and it seemed to kind of flatten, but we're going to go at 200,000 there. I at least will. Let's see if that gets us anywhere. And it's still way off. But I got my X figured out, right? I've got the x-intercept here on that end, so I'm going to go window. How about I go over 1 million, I think it used to be. Yeah, let's try that. Oh, that's way over. 500,000. It's more than a million, right? That's why. There. 1 million doesn't quite do it yet for me, so I'm going to go 1,500. Try that. And there it is. Okay, perfect graph. Second trace 4. Go to the left. Go to the right. And that's 447. So I'm going to go second, trace 5, or max. Sorry, it's 4, right? Second trace 4. And it's 447.50. And it's 123,6149.7. So you write down the point and then you tell me max price would be 447.50. Okay, it's because it's L1 was the price, this is the profit. So this is the price that will give you the highest profit. And then see what is the maximum profit. You just literally write down this number here. 1,236,149.70. Technically a monetary amount, by the way, in grade 12 applied, you need to have, you can't leave it 0.7, it needs to be 0.70. I don't know why, they're very picky with that. If not, you have to take off half a mark. D, how many seats will the arena fill with a ticket price in B? So remember that the profit that you have here is always the product of the price times the tickets. So tickets will be profit divided by price. Okay, so that's 123,6149.7 divided by 447.50. The tickets sold would be 2762.34, and it keeps going, which is approximately 2762 tickets. Right? You can't have a decimal because it's discrete, right? Like we're talking number of tickets, so you can't do that. E. Oh, there's two E's. Okay. That's okay. If the owners want to profit at least 950,000, what price or prices should they charge? Determine the tickets sold at the different prices. So basically, you're going to make Y2 equal to 950,000. And then we're going to go second trace 4 2 times, right? So let's go ahead and graph this. And there's the 950,000 profit margin that you want. So it happens at a ticket price here and at a ticket price here. So you go ahead and find, there you do 5, sorry, it's intersect. Change that to 5, okay? So you're gonna find this one first, and that is the price here. Price number 1 would be 232.19. Price 2 would be 662.19. 0.81. And I'm running out of room, but you're literally just going to go 950,000 divided by that to get you your tickets here. Tickets for price 1, tickets for price 2. You're going to get them individually there.
And that's 232?
232, yeah, 19. So that's 4,091. And here it would be oof, that's not right. There you go. 1433. 1,433. And those are approximate numbers, right? Like they're decimals, but we're rounding them here. Ideally, I would like you to write down the decimal and then the rounded value. What are the domain and range here? Domain and range. Range you already know. Range is your profit in this case. So it goes from $0, right? It goes from 0 all the way to 1,236,149.7. There it's okay to not have the 0. And the domain, you need your x-intercept for that. So we're going to go ahead and find that. We're going to make y2 equal to 0. And again, all of these things, right? You had lots of time to get back and review this, right? So from 0 to 895. So that would be your break-even point, right? Selling 895 would get you a 0 profit. So you would break even there. So you found the x-intercept, which will also help you to graph, okay? And so we need all the way to almost 1,000 here. So if you go up by 250 here, that's fine. This is price. Oh, sorry. This is not the number of tickets, guys. This is our domain here for equation in A. This means the price per ticket. So selling it at $8.95 per ticket would give you a break-even point because you wouldn't sell a whole lot of tickets, but it's a high price per ticket. And so here we need to go up by a scale of 250,000 to make sure we account for all of it. 1,250,000. So you have to be comfortable with bigger numbers. So this is the price in dollars. So you have to have units as well, right? Or if it's number of tickets, and here it's profit, and it's also in dollars. So it's 00, and then it's about 900, almost 900. So there. And the maximum is reached at a price of, right? Go back to the vertex. It's 447, somewhere in here, and it's 123. So it's right about there. Okay. You go up, kind of curving, come back, and there's your graph. And your equation, and it's all done. Does this all come back? Is this all coming back? I hope so. I know I'm going faster, but at the same time, the key is out there, right? And at some point, right, like I gotta let you go, right? I gotta let go of your hand and you have to like study on your own and show me what you can do. No, that wrong room. Sorry. This is cabin 3. He's in P004. If it's the new fault that I know. Okay. Page 4. This is the last one I'm doing. And then we're done. I'll do the attendance and then how about I'll pause, you get started. We're good. All right. This is a story, the story where you have to come up with the 3 points, which was also on the test. Okay. So Ariana wants to perform a stunt which consists of jumping off a trampoline and landing on her deck. Her trampoline is 4 feet off the ground, while her deck is 3 feet off the ground. During her stunt, she reaches a maximum height of 7.5 feet after 1.25 seconds. Sketch this scenario and label at least 3 points. And by the way, right, that should tell you, it's like, oh yeah, the 3-point thing, right? I need a regression. Okay, so when it's sketch, you don't need to have a perfect graph, but you should at least have, right, like there should be time, and this is height, and it doesn't need to be perfect. So, right, if this is the trampoline here, right, and this is the deck, right, the deck is slightly lower, so the stunt starts here, right, jumps and then lands here, right, and it's slightly, right, the height difference should be noted here. It's about a foot, right, about a foot difference there. And so you start at 0.4, right? At time 0, you're at 4 feet. And how about this? You graph this first and you kind of imagine what's going to happen. And it stops here. Like, unlike most of our examples, it just get rid of that. Right? Most of our examples, this thing hits the ground, or hopefully this person doesn't, Ariana doesn't hit the ground, right? That would be very bad. But you know that, you know this point, and you know that the height here is 3 feet off the ground. Let's see if that helps us. We don't know the time. This is question mark here. But you do know that the maximum height, which is the vertex, happens after 1.25 seconds, and it's 7.5 feet. Okay? So given, you need to come up with a third point. Oh yeah, it takes 1.25, so it'll take another 1.25 to get to here. Right, not right. So you got to basically make a dashed line from where you started and make that third point. And this point is, yes, times 2, and it's 4 again, right? 4 feet, 7.5, and then back to 4. What about this, Mr. Dirksen? It's for later, okay? Let's just park it there, but you have your 3 points. So determine the quadratic equation. I will do this here. 0, 4, 1.25, 7.5, 2.54. If you can't see this, start highest point back to the start, you're doing something wrong. Okay, L1, L2, stat calc 5. Oh. There it is. Negative 2.24 x squared plus 5.6x plus 4. Got your equation there. How long does it take to reach the deck? That's when this is going to come in handy. because you know it happens at a height of 3. So you're going to find out this time. Okay, so that's where, so it happens when she reaches a height of 3 feet. So we'll let y2 equals 3, and then its second trace 5. Okay. Oh, I need to do the zoom 9 thing again. No, what? Why did I do 5? It's 3, right? And it's probably not going to be on here, so I need to change my window slightly. X max, let's go 5, -1, 10. There we go. And it happens, don't worry about this one. This one is not invisible, right? It's negative time there. It's this one here. And that would be 2.673 after 2.67 seconds. Right? This is now the time you found here. So I did trick you a little bit. I really wanted you to think, right? And that's so this question does not have an x-intercept. Your x-intercept is almost like higher up here now, right? This is the y equals 3 line. So that's when the story ends, right? The action. D, domain and range. You gotta be good at that. Next year it's gonna be asked over and over, and these are restrictions, right? And so time from 0 to 2.67. Range, tricky. The lowest you ever get is 3. The highest you ever get is 7.5. That is your range there.